going out, that is not good. So it is expected that all students should be available in the classroom. Okay, so this one, our lecture number 32. In lecture number 31, we have seen the design of the three-loaded column. We started with 3. We have seen uh, how the eccentricity are there on the column, and there are certain reason is due to the axial force and acting some distance from the CG of your column, building frame action, porter or bevel frame action, all these things we have seen. Load from the bracket, transverse loads from the beam or girders, fixed base conditions of the column. Okay, so these are the situations where the eccentricity is observed in the column, and then we have seen the how to design this column step by step procedure in the previous class. In today's class, also have seen how to find out all the values by interpolation from the given. You may use the numerical equations also to find out. And this is the last condition where the actual force N divided by ND, the design strength in compression, ND, then moment about y-axis about design moment about y-axis, moment about major axis about z-axis, so the design moment about z-axis should be, if it is equal to less than 1, then we will say that our column is safe or selected section is not. Okay, if the section is given, then you don't need to be selected. This is step number 1, to assume the FCD and to find out the uh, section so that you escape from that. And this one to escape is not required if already section is given in your example. And also I explained the eccentricity with the bracket is the uh, eccentricity, it may be uh, the load acting away from the CG of column. If it is one side, then it is called as uniaxial bending. If it is two side eccentricity along the major and minor axis, then this is termed as biaxial bending. Okay, and how to find out the moment my p into ey and z into p into ez. From that you can find out the moment coming on the column, and then you have to define this column as a beam column. It is called as column with the bending, that is nothing but called as beam column. So we'll start one example today, and we'll solve, then we'll be able to understand how to design the eccentric column. Okay, so I will start. Today is date 23, time 21, DSS. The student joining in and making out is not permitted because our whole lecture is recorded. Our lecture number 32. Write down this example. You should sit with the pen and paper, write down this example, and try to solve with me. Example of eccentric column, example of uniaxial bending. Or you can say that column, or you can say that design of eccentric column. Design of eccentric column. If the eccentricity is about only one axis, then that column is termed as uh, the column is termed as uh, eccentric column, uni-eccentric. If the eccentricity about the both axes is termed as bi-eccentric. So this is column and this is our major axis, you can say z axis, and minor axis, you can say y axis. So eccentricity is of the loading is only in one direction, then called as this is called as uniaxial bending. This is called as uniaxial bending. Okay. And if eccentricity of the column from the both axes your minor axis, your major axis, your load is somewhere here. Okay. So you can see that this is eccentricity about the z axis also, major axis also, and eccentricity about the minor axis. Okay, so that is nothing but this type of column they are called as biaxial bending. And up till now we have designed, column with axial force only, and what we are considering, the load is acting at the effect CG of your column. So this is the axially loaded column. Axially loaded column. तो अभी तक हम लोग ने जो डिजाइन किया है वो क्या किया है, एक्चुअली लोडेड कॉलम की. नाउ विथ दिस एग्जांपल you will solve or check the adequacy of the section. Check the adequacy of the section of the section of the section. Check the adequacy of the section. ISHB 450 about 87.2 kg per meter, or 87.2 kg per meter, to carry axial compression of axial compression of axial compression of 750 kilonewton. The load on your column is 750 kilonewton at an eccentricity of at an eccentricity of at an eccentricity of 270 mm. 270 mm about its major axis. About its major axis. Its major axis major axis. The effective length of column, the effective length of column, the effective length of column is the full length of column. Full length of column. Just 3 meter. 3 meter. Consider only section strength. So to check only, consider only section strength. Section. So this example you have to solve. Okay. This is the example you have to solve. This example you have to solve. This is example, and you solve this example. So okay, I will start solving this example. So here what is given? So I don't know. This is the first step. So section is given. Section is given. ISHB 450 about 47.2 kg per liter. ओके, दूसरा क्या दिया हुआ है? लोड, कॉम्प्रेसिव लोड, फैक्टर्ड लोड इज गिवन. Factored compressive load. It is not factored, then you have to do the factor. But is already factors compressive load is given. And this is we are going to get P is how much? 750 kilo. Also, eccentricity about major axis is given. Eccentricity about major axis, that is 270 mm. Major axis generally we are denoted the Z axis, that is given 270 mm. Okay, I will write on this is PZ. Okay. Now section is given, then you can write down the properties of section. Write down the properties of section. But we require the properties of section for our calculation. Okay. So first we have to write down properties of section. Properties of section. ISHB, ISHB 450 about 37.2 kg per meter. So what is the properties of section? You have to write down what is the depth. Depth is nothing but B or H 450 given. Is given. BF is the width of length, P is the thickness of length, PW the thickness of the we will check all these things. Okay, and cross section area, AG, cross area of the section. So write down. So H is 450, width of length is given 250, thickness of length. Thickness of line is given 13.7 mm. Thickness of width given 9.8 mm. These all values I have taken from where? steel table. Okay, somewhere it is 1 square. Okay, so if you see the steel table, it is given at the last of the section property is given in plastic section at the last of your IS code. You see the section properties is given. You can take from there or you can take from here it is given the section property with the ISHB 450, ISHB 450, 450, 450, 37.2, you can see. Okay. The area is 111.14. Okay. Depth of section is given 450. Width of flange is 250. You can see here, or this is width of flange. Thickness of flange is given 13.7. Thickness of breadth it is given 9.8. Radius of gyration about z-axis it is given 18.7 centimeters and 187.8. Radius of gyration about 1.8. So on return 187.8 is the RZZ 157.8. And then similarly RYY, no need of calculation, it is directly given. All these are the section properties. Then you can see is section modulus and then plastic section modulus. So section modulus, plastic section modulus. Plastic section modulus is also given here. Plastic section modulus and elastic section modulus, that is also given. So ZEZ is 1742.7, 1742.7, 1742.7 equals to 3 mm and ZPZ is also given. Elastic section modulus it is 1955.03, 1955.03 10 to 3 mm cube, that is given in centimeter cube. If you convert, then you have to multiply with 10 to 3. These are the sectional properties of the section which is given, and shape factor 1.1218, shape factor nothing but ZP upon ZE, and it is already given 1.1218. Okay, so all these properties of section we need in calculations. So whichever properties of section we need, we have to write down. So this is step number 1. You have to write down what is the given, and if the section is given, then also you have to write down the sectional properties of that section. Now we have to calculate the loads. So, second step, if I write down second step, load or forces calculation. So load, axial load already factored, axial load PU, factored axial load PU is already given, that is 750 into 10 raised to 3 Newton. And mu you have to calculate. How you can calculate load into eccentricity. Eccentricity is given only about major axis z. So mu z, you can write down mz directly. The moment about the major axis is nothing but p into z. So 150 into z to 70 mm. That is calculate. So it is coming 202.5 into 10 raised to 6 Newton mm, or you can write down the mz is equal to 202.5 kilonewton. Okay, so this is step number 2. Now we'll write down step number 3. Step number 3 is step number 3. Step number 3, you know the sectional properties. You need to find out the section classification of section. Section classification. Why section classification is needed? To find out here effective area is equal to AG or not. Okay, if AE is equal to AG, कब रहेगा? If your section is plastic, class 1, or if your section is compact. In that case, class 2. In that case, only your AE is equal to AG. So, section classification we are doing as per the IS code table number 2 of table number 2, page number 18. So here you can see the limiting width thickness ratio. Based on that classification of section, you can say class of section. Okay, class 1 plastic, class 2 plastic, compact, class 3 semi-compact, and class 4 cylinder. And cylinder section we are not designing in our case and not permissible because it fails before the yield stress. Okay, so how to do the section classification is already many times I have discussed. Now also you can see how to do the section classification. So we have to find out. First, I will take the flange element. So df by 2 by tf is equal to. So to find out this, because our I section is there. So for I section, you can see what is B. B is the BF by 2 here. Okay, and B is the depth of web only. Depth of web only. Okay, so if I write, so BF by 2, then 250 divided by 2 upon TF, TF 13.7 I think so. It's 125 by 13.7. It is coming from 9.12, which is, so if you say in table number 2, you can see here outstanding element of compression plane rolled stitch section, because our rolled stitch section B by TF ratio is 9.4 से अगर कम है तो we will say that this is class 1 class 2. So in our case 9.12 is less than 9.4 epsilon. So we'll say this flange is plastic. That is class 1. Class 1 plastic. Okay. So this limiting value. And what is the E? E is many times told you it is under root of 250 upon Fy. Or Fy is 250. So 250 upon 250. 1. Under root of 1 is 1. That's why this is 9.4. So that's why this value is less than 9.4 you can say it is class 1, class 2. Now, another element is the width, that is D by TW ratio. What is the D here? D is nothing but H minus or D minus or capital D minus 2 times R1 minus 2 times TA. So it is 450 minus 2 times R1. R1 is radius at root. So radius at root is you take from the steel table. So radius at root, if you take from the steel table, is somewhere. Go to the steel table. ISHB, ISHB 450 about 87.4 kg. ISMB is equal to ABHB WB CHB. So you can see here ISHB 450 about 87.2 kg. So we go for R1. Where is given R1? This is IXX, IYY, RZZ, RYY, ZX, ZY. Here R1 and R2. So this first value R1 is given here 15 mm. So R1 is 15 mm. So R1 is 15 and 2 times 15 minus 2 times TA is 13.7. So you get the value of D after calculation. So the value of D is 2 into 15 is 13, 13.7 into 2 means 27.4 plus
392.6.
30, 57.4, 450 minus 57.4, it is coming 392.6.
92.6.
So it is coming 392.6. So I will write down here 392.6. TW is already from sectional properties. We have written here. This TW is 9.8. So I will write down here 9.8. So it is coming around divided by 9.8. It is 40 point something. 40.06. Again, we have to check from the I score. So this is wave of I. Here you can see the wave of I section. Neutral axis at mid depth. So definitely symmetric section is where the neutral axis is at mid depth. So D by TW ratio, if it is less than 84 epsilon, it means that it is class 1 plastic. So our 40 is less than 84 epsilon. So the weight is also class 1. In class 1 is nothing but plastic section. So flange is plastic, web is plastic, is meant as the section is plastic. Section is plastic. It means that if your section is plastic, it means that the effective area A is equal to H. Effective area A is equal to. Okay. Now we'll go to find out step number 4. Design strength of compression building. Design strength. Design strength in compression, due to yielding of section. And that is nothing but ND is equal to AG into Fy upon gamma M0. That is AG is nothing but here A into Fy into gamma M0. So AG is equal to 11114 mm square into Fy is 250 divided by gamma M0 from table number 5 of I score. Table number 5 of I score. It is given here page number 30 पर दिया है gamma MO is term governed by index gamma MO is 1.1. So write down gamma MO is 1.1. If you find out the MD is coming around 11114 into 250 divided by 1.1 is coming
Two point nine
2525.
one nine into 10 raised to 3.
2525
Point 9
9 into 10
into
to
10
3
raised
Newton. If I write down in kilometer, it will be 4525.9 kilonewton. This is your strength in English. Now we know that the effective length of section, we know that the effective length of section, it is already given in LE. LE is generally we write down K into L because it is already given. L is 3000. The LE is already given, that is 3000 mm. 3 meter means 3000 mm. Okay, this is the effective length of section. Or otherwise अगर नहीं दिया effective length unsupported then L दिया है, so you can find out the value of K from table number 11 at page number 55. From there you can find out the value of K, and LE is nothing but LE is nothing but LE is nothing but K times L. You know the supporting condition, then you can find out the value of K from table number 11, page number 45, and is given I score from table number 11. These conditions already. Okay. So from the end conditions, you can find this equivalent value is K, 2L, 1L, 1.2L. As per the support condition, that already we have discussed earlier, so we don't need discussing here. From this table, you can find out the effect. Then you know the R minimum, and you know the lambda is equal to LE upon R minimum. So R minimum in I section, remember about the minor axis is 51.8. So if I write down 3000, this is the AD, R minimum is 51.8, lambda will be, lambda will be 57.91. Lambda will be 57.91. All these properties of section already I have written here. Okay. Already I have written here. From this you can take the value RYY, RZZ. So this one is the minimum RYY. Hence, here R minimum is taken to find out the slenderness ratio. So because where the maximum slenderness ratio is there, the bending of column will be from that direction. That's why we are taking here R minimum. R minimum always use the maximum slenderness ratio, lambda. Okay. Now, step 6, you have to find out. Step 6, you have to find out. Now you have to find out critical stress. Critical stress. Critical stress of your section. And it is denoted by FCRB. It is denoted by FCRB. The FCRB you can find out by the empirical equation given in the IS code. Okay. Or otherwise, FCRB you can find out from the table. In the table. Okay. So to come to here, the column with the bending. Okay. The column Design of member subjected to bending. Come to here. Its span is given. Okay. So here the empirical equations are given. MD is equal to theta B ZP Fy upon gamma of 0. But in case of comparison member, this given equivalent of lambda LT is under root of Fy upon HCRB. And this is where design bending compressed bending the PD based on the value of alpha LD. Alpha LD, this value is based on the section, roll listing section or build up section. Roll listing section is there, then alpha LD is 0.21. And if so, that's alpha LD point build up section 0.449. And this is the table 14 for the critical stress FCRB. FCRB you can find out from the empirical equation also. This by using this empirical equation, this will give you the exact value. Alpha LT is equal to lambda LT. So for welded section, it is alpha LT is 0.49, and for roll listing section, alpha LT is 0.21. So lambda LT you have to find out Fy upon under root of FCRB. And FCRB, extreme fiber bending compressive stress, you can find out from table, or you can find out by putting this value 1.125 square E upon LTR Y under root of 1 plus 1 by 20, then in bracket LTR Y divided by HF by DF square. Okay. So it depends on the HF by DF value also as it is here. Okay. So this empirical equation also you can use to find out the FCRB, or directly from table number 14. From this table you can find out the FCRB. So I will use this table. HF by TF value हमको मालूम करना पड़ेगा. KL by R is already known to us. LE by R minimum, and this is HF by TF value. So from this HF by TF value we will find out critical stress using table. So I will write down. I will find out FCRB by using table. So for that we know HF by TF value. This value we know. ये मालूम करना पड़ेगा. And HF is nothing but center to center distance of compression flange. So this we can find out easily. HF is nothing but capital D minus 2 times of EF by 2, means that D minus TF is nothing but increase 450 minus 13.7, which will give the HF value. So 450 minus 13.7, it is given 436.3 mm. HF by TF. HF value. Now HF by TF. HF is 436.3, TF is 13.7. So it's right on this. 436.3 divided by 13.7. HF by TF value is coming 31.84. 31.84. And lambda we know, lambda already we are talking 7.9 clear. Okay. Now these two values we know, but the HF by TF value for 30 and for 35, the value is given. And for lambda value, this is HF by TF value. For lambda लैम्बडा हमारा कितना है 57.91, लेकिन 50 लैम्बडा के लिए वैल्यू दी है और 60 लैम्बडा के लिए वैल्यू दी है. ओके, द वैल्यू इज फॉर 50 और 60 of df और फॉर 30 SF by TF वैल्यू ये लैम्बडा की वैल्यू. तो अगर मैं यहाँ लिखता हूँ, मुझको मालूम करना है 31.84 के लिए, तो इसके लिए वैल्यू नहीं दी है, इसके लिए वैल्यू दी है. तो दिस वैल्यू यू फाइंड आउट बाय मेनी इंटरपोलेशन. और 50 के लिए जो वैल्यू दी है आप देखेंगे यहाँ पर 50, ये 50 है लैम्बडा 50, एच बाई टी एफ वैल्यू 30 के लिए हम देखेंगे तो इट इज 30 के लिए 927.1, 927.1 और 35 के लिए 9112. इसी तरह 60 के लिए 660.9 और 646.1. So these values are given. So we are write on these values. For 50, it is 927.1. 30 के लिए दिए, इसके लिए नहीं दिए, ये हमको मालूम करना है. और 35 के लिए दिए 912. I'm not wrong. Okay, we are seeing from the table. Now this value for this we don't know. We have to find out. Now this for 60 it is given 660.9 and 646.1. So now we have to mainly we need to find out this value. ये हमको मालूम करना है 31.84 HF by TF वैल्यू और 57.91 के लिए. तो हम क्या करेंगे, पहले हम 50 का इंटरपोलेशन करेंगे. इसका इंटरपोलेशन करेंगे पहले हम लोग, ये 50 का इसका इंटरपोलेशन करेंगे, फिर 60 का इंटरपोलेशन करेंगे. तो हमको ये वैल्यू मालूम हो जाएगी और ये वैल्यू मालूम हो जाएगी. ये दोनों वैल्यू जब मालूम हो जाएगी तो फिर हम इसका ये दोनों वैल्यू का इंटरपोलेशन करके ये फाइंड आउट दिस वैल्यू. इंटरपोलेशन पहले कैसे करता है मैंने आपको पहले ही बताया. I will take this higher value. If I write down 927.1 माइनस, है ना, तो मैंने 50 से लिया तो यहाँ पर 57.91 माइनस 50 डिवाइडेड बाय 60 माइनस 50 इंटू extreme value is 927.1 minus 912. तो इस तरह हमको इंटरपोलेशन करना रहता है. तो 9 अच्छी से मैं लिखता हूँ 927.1 माइनस हायर वैल्यू मैंने लिया तो जिससे रिलेट किया 57.91 माइनस 50, क्योंकि 50 की वैल्यू है ये इसलिए ये 50 से माइनस होगा, divided by 60 minus 50 into extreme value 927.1 minus 912. ओके, अब इसको जब मैं सॉल्व करूंगा तो यहाँ मेरी पहले इंटरपोलेशन की वैल्यू आ जाएगी. इफ आई विल सॉल्व दिस तो 57.91 is nothing but 7.91. This is nothing but 10. Okay, I have to find out this difference. 927.1 minus 912 is coming 15.1. तो अगर मैं लिखूंगा तो 927.1 माइनस क्या हो जाएगा 7.91 डिवाइडेड बाय
91.15
into 15.1. So it is coming 7.91 into 15.1 divided by 10. It is 11 point. This value is 927.1 minus 11.94. 927.1 minus 11.94, it is 915.15. So this first value just now I will get It is 915.15। इसी तरह इसका इंटरपोलेशन करेंगे, तो इसका इंटरपोलेशन अगर करेंगे तो अगेन दिस इज 660 माइनस 0.9 माइनस 660.9 minus 57, oh sorry, something wrong लग रहा है, हमने कुछ गड़बड़ कर दिया यहाँ पर, because this is not, no, this is 31 and so this is wrong, right? Here it will come, sorry, please do the correction, ये सही है, यहाँ पर आएगा, please do the correction, because we are interpolating the first is wrong, use this, so this is 30 और 35, तो यहाँ पर आएगा आपका 31.84, sorry, again write down 31.84 और यहाँ 30 and this is 35 minus 30, sorry, and this is okay, 927.1 minus 900, this is okay. Again do the interpolation, यहाँ पर मैंने गड़बड़ कर दी थी, तो सही कर लो आप, make the correction, because I am interpolating about this square value final, I am interpolating between these, so 30 or 35 and 31.84, इसके बीच में आप interpolation करें, write down, recalculate, 31.84 minus 30 is 1.84, sorry, this 1.84, this is 5 difference, and this difference is same, 15.9. So if we solve this 1.84 into 15.1 divided by 5, is coming 5.56, 927.1 minus answer is 921.54.
54.
Now it is correct. Okay. तो इंटरपोलेशन करने के टाइम में किसके बीच में कर रहे हैं वो जरा ध्यान देना पड़ेगा, यहाँ पर उससे गलती हो गई, आपसे भी गलती हो सकती है, इसलिए ध्यान देना। ये हम लोग ने 50 के लिए ये वैल्यू मालूम करें फॉर 50, नाउ फॉर 60 ये वैल्यू मालूम करेंगे, तो उसका इंटरपोलेशन अगर हम करेंगे तो फिर 660 सेकंड वैल्यू, ये फर्स्ट वैल्यू 660.9 minus, here it is same 31.84 minus 30, again it is 35 minus 30, and extreme value 660.9 minus another value is 646.1, 646. Now this difference, six six zero point nine minus 646.1, इसका डिफरेंस है 14.8. Other all this we know, pi and 1.82. If you calculate 660.9 minus, so this will be 1.84 into 14.8 divided by 5 is 5.44, 660.9 minus answer it is 655.
Minus 45.
0.45. So this is second value, you know, 655.45. So we will stop here and we will complete this example on next lecture. So I will thankful for you because the power is off. I have to show, otherwise my laptop will go off. We'll continue this lecture later on. So thank you for joining.